All right, so in this particular mole conversion video, we have the first problem here. It says how many moles of atoms are contained in 78.4 liters of neon or Ne, which is a gas at STP, standard temperature and pressure. So there are a couple ways to do this. I like this particular first approach because it uses stoichiometry strategies. So the most important thing to recognize is that to do these problems correctly, it must be under STP, or standard temperature and pressure. And if that mentions STP, one piece of important information that you should know is that for every 1 mole of gas, it occupies 22.4 liters of volume. Okay, so this particular conversion factor is essential. 1 mole is 22.4 liters. Well, once you know this conversion factor, it's super easy to do. I like to start with the information given in the problem. It says here 78.4 liters of Ne. So I'm going to start with my work here with 78.4 liters. I like to put that over what I call the sexy 1 for my chemistry kids. There's the 1. And then from here, really, we're just converting liters to moles. So in order to do so, I would just set up this particular chart. What you have to recognize here is that you have 78.4 liters in the numerator. Well, you don't want liters, you want to go from liters to moles. So this is what this conversion factor in yellow allows us to do. It gives us the ratio, allows us to go from moles to liter, liters to mole. So therefore, in the next step, you need to put the 22.4 liters from this conversion factor in the denominator. You want to cancel out units, okay? This is 78.4 liters in the numerator. So therefore, the units of liter has to go in the denominator in the next step. Well, if you're going to put liter in the denominator in the next step in order to cancel out the units, you also have to put the right value. And it's super easy to put the right value. Just look at the conversion factor. It says 1 mole is 22.4 liters. So in front of liter, you have 22.4. So keep those values, or keep the units and the numbers the same. Okay, so 1 mole goes on top. So therefore, this statement is true. For every 1 mole, it occupies 22.4 liters of volume, or vice versa. So make sure you put the values in the right slot. Otherwise, you're going to take an easy task and complicate it. Okay. If you do this correctly, liters will cancel out. I have a liter unit on the top. I have a liter unit on the bottom. So as you can see here, this is pretty light work. We have 78.4 times 1 mole. Well, we can just stop here because the question is asking how many moles, right? You don't need to take it any farther. So recognize how many steps to do. In this case, really you're just doing 1 step. So I already canceled out liters in my work. So right here, I'm just going to multiply across. 78.4 times 1 mole will give me 78.4 moles. And then 1 times 22.4. And notice down here, there's no unit because you already canceled the units of liters in the work. So therefore, the only thing to carry over for this particular problem is 22.4, because 1 times 22.4 is 22.4. Well, here it's just calculator work. 78.4 moles divided by 22.4 will yield 3.5 moles of any gas. So that's our answer. Okay. So to convert moles, to convert liters to moles, it's pretty straightforward. However, this is an alternative method. Depending on how you see these types of problem, this method uses ratio. So sometimes you can put 1 mole over 22.4 liters because this is a true statement. 1 mole is 22.4 liters. And this particular problem uses ratio, which implies that you need to know where to put the starting point. The starting point here is 78.4 liters. So you got to make sure the units correlate. So you see on the left side here, where it says 22.4 liter, on the right side, it also has to have the same unit. So in this case, 78.4 liters has to go in the denominator on the right side. And you're trying to find what the mole is. So you notice here I put a question mark. I don't know what this number is, but I know if I find the right number, it will reduce down to the same ratio, 1 over 22.4. Okay, so this method uses ratio. Okay, but that's fine, right? This particular approach is not too bad. Here, your question mark, I'm just going to replace with x because that's what I'm trying to find. I don't know what this x value is, okay, the number of moles. So I'm going to call it x. So in math, when we don't know something, let's just assign it a variable here. I've chosen to assign it x. Therefore, in order to solve for x in this particular work, I need to get rid of 78.4 liters. your sum for x, aka get x by itself. So in order to do so, we do the opposite operation here. So instead of dividing by 78.4 liters, you're going to multiply both sides by the same value. In doing so, you can get x by itself. So therefore, I multiply both sides by 78.4, and I also multiply the left side here by 78.4. And then if you notice here, liters will cancel out nicely. Liters in the left side here will cancel with the liters. So the only unit left over is moles, okay? So as you see here, you can just multiply across 78.4 times 1, which is 78.4. And then the bottom is just 22.4. So if you take 78.4 divided by 22.4, which practically is the work initially at the beginning of the video here, okay? And that will simplify down to the same answer. So therefore, 78.4 divided by 22.4 will also give you 3.5 moles of neon. All right, so when you do this particular approach, just make sure you know where to put the value. And the good rule of thumb is make sure the units matches. Okay, so if you want, you can flip liters up, but if you do that, then you have to put 78.4 liters up. So you can flip the whole entire function upside down, but as long as liter is in the same line, you should be okay. All right, I hope that helps. Stay nerdy, don't be whack.